In this lesson, we're going to review elimination, which is a method used for solving a system of equations. So here we have our system, 4x plus 2y equals 8, and negative 2x minus 2y equals 6. So what we do in elimination is we're going to add the equations together in such a way that one of the variables cancels out. So if we look at this, if we add these, let's add the x's. 4x plus negative 2x is 2x. 2y plus negative 2y cancels out. And 8 plus 6 equals 14. So now we have an equation with just one variable, 2x equals 14, and we can solve for x. But let's take a look back at how this worked. First, the equations have to be written in the same format. So here we have the x term plus the y term equals 8, and here we have the x term plus the y term equals the number. This way they line up correctly when we add them. Another important aspect is that when we add them, one of the terms has to cancel out. So in other words, the 2y and the negative 2y cancel out perfectly because they have the same exact term, except one has a plus in front of it and one has a minus in front of it. So we have to have it in this form in order to use elimination. Okay, let's continue the problem. So we'll just solve for x. So 2 times x equals 14. We can just divide by 2. And we get that x equals 7. And now we'll use this value of x to solve for y. So let's take the first equation, 4x plus 2y equals 8. So substitute 7 in for x. So 4 times 7 plus 2 times y equals 8. 4 times 7 is 28 plus 2y equals 8. Subtract the 28 from both sides. And we get 2y equals negative 20. Divide by 2. Divide by 2. And we get y equals negative 10. So our solution should be that x equals 7, y equals 10, or 7, 10 written as coordinates. But let's check it. So we used the top equation to solve for y. So let's check in the bottom equation. So negative 2x minus 2y equals 6. X is 7, so negative 2 times 7 minus 2 times negative 10 equals 6. It's going to be negative 14 plus 20 equals 6, and we get that 6 equals 6. So that checks out. This is our solution. In this system of equations, again we have two equations, two variables, and if we want to use elimination, we have to make sure they're in the same order. So we want the x term plus the y term equals some number. So look at this one, we have the x term equals the y term plus a number. So they're not written the same way. Let's change this so we have next term, then the y term equals the number. So we have to set it into this form first. So we have to bring this y term over to the left. So we'll do minus 4y from both sides. So we end up with 4x minus 4y on the left. On this side we just have the 9. So we have 4x minus 4y equals 9. So now our two equations are 3x plus 4y equals 5. And 4x minus 4y equals 9. Okay, at this point we can add them together. and use elimination because we have the x's in line, the y's in line, the equal sign in line, and the numbers in line. And of course we see when we add these, the y's are going to cancel because we have a plus 4y and a negative 4y, so it should work out perfectly. So 3x plus 4x is 7x. This is gone. And 5 plus 9 is 14. So now just divide by 7 to solve for x. Find that x equals 2. Okay, now we'll use this to solve for y. So let's put this into the first equation. So 3x plus 4y equals 5. So we have 3 times 2, because x is 2, plus 4y equals 5. 6 plus 4y equals 5. Subtract the 6. And we get that 4y equals negative 1. Last step, divide by 4. Get y equals negative 1/4. So our solution would be 2, negative 1/4. It is okay to get a fraction as one of the variables. So again, when they're not written in the same form or the same format, just manipulate the function or the equation by bringing all the terms into the order you want them to be in, and then we could use elimination. Let's look at this example of a system of equations, and we'll try and solve this using elimination. If we look at this, we'll notice that when we add these, nothing's going to cancel out. It's in the correct format. We have the x, the y equals, and a number. Everything is lined up correctly. But when we add this, we're going to get 5x, here we'll get 3y, and we'll get 7. None of the variables cancel out. So we have to change one of these equations so that when we do add them, something will cancel out. To change it, we just multiply by a constant. So in this case, we can multiply this bottom one by 4, so that this will become positive 4y, and this will cancel out. So the method is just pick a variable you want to eliminate, and then pick the number that you have to multiply it by so that that one eliminates. Don't worry about what this is going to come out to. Just worry about the one variable you're looking at. So we're looking at y. We have to multiply this by 4 to make it 4y, then it'll cancel. So the top equation stays the same. We have 3x minus 4y equals 2. And we have to multiply everything by the 4 on the bottom. So this becomes 8x plus 4y. Okay, remember to multiply this side by the 4 also, equals 20. Now we could use elimination. So we add these together. We get 11x, the y's cancel, equals 22. Divide by 11. And we get that x equals 2. Now we can use this to solve for y. We just plug it in. So 3x minus 4y equals 2. 3 times 2 minus 4y equals 2. 6 minus 4y equals 2. Subtract the 6 from both sides. I'll write it over here. We're going to end up with negative 4y equals negative 4. Divide by negative 4. And we get y equals 1. So our solution is 2, 1. So again, we had to multiply one of the equations by a number so that the variable would cancel out. Let's look at a second way of doing this one. Okay, we wanted to get rid of the y, so we multiplied it by 4, so they cancel out. But what if we want to get rid of the x's? Well, in this case, there's not an easy number to multiply either of these by so that they cancel out. So what we have to do is have to multiply both of them by different numbers. So all we do is think about what's a common multiple of 3 and 2? Well, 6. So it's possible to multiply the top by number to make it 6 and the bottom by number to make it 6. So we have to multiply the top by 2 to make this a 6x and the bottom by 3 to make this a 6x. Okay, but that's not all, because we want them to cancel out when we add. So if we have 6x and 6x, when we add them, we're going to get 12. They're not going to cancel. So you have to multiply one of them by negative. So make sure that one of them becomes negative and the other one's positive. So now let's multiply the top and bottom. So on top first, we get 2 times 3x is 6x. 2 times negative 4 is negative 8y. And 2 times 2 is 4. Okay, now here distribute the negative 3 to each term. So negative 3 times 2x, negative 6x. Negative 3 times y would be negative 3y. And negative 3 times 5 would be negative 15. Now when we add, the x's cancel out this time. And we have negative 11y equals negative 11. So just divide by negative 11 on both sides. I get that y equals 1. Just like we found this way. So I'm just going to use this to solve for x. So we take one of the original equations. 3x minus 4y equals 2. So 3x minus 4 times 1 equals 2. 3x minus 4 equals 2. Add the 4. Get 3x equals 6. And the last step, divide by 3. We get x equals 2. So again, our solution is 2, 1. So sometimes it's possible to multiply one of the equations by one number in order to get the one of the variables to cancel out. Or you could always multiply both equations by different numbers such that one of the variables cancel out. Just make sure that whatever you're trying to cancel out, so in this case the x's, the coefficients were 3 and 2, so we had to multiply them so that they became a common multiple of 3 and 2. And of course one's positive and one's negative, so they cancel out when we add them.